If you haven't heard yet, our solar system has a very unusual visitor right now. Comet 3 I/ATLAS suddenly appeared on the astronomical scene in early July 2025, first spotted by the NASA-backed ATLAS Survey Telescope. That's the Asteroid Terrestrial Impact Last Alert System, located in Rio Hurtado, Chile. Since then, scientists all over the world have been racing to learn everything they can about this mysterious comet. There's been a flood of articles, alerts, research papers, and even some controversies. After all, this is the first interstellar object to pass through our solar system in 6 years. But with all the hype, what do we actually know about 3 I/ATLAS? What's real science, and what's just speculation? I'm Alex McColgan, and you're watching Astrum. In this video, we're cutting through the noise to give you the latest updates on 3 I/ATLAS, just in time for its perihelion on October 30th. Even if you're not a scientist, this comet is proof of how exciting and unpredictable space research can be. Back in July, when I made my first video about 3 I/ATLAS, there were only about 4 published papers on it. Fast forward to September, and there are nearly 70. That's a lot of new discoveries and facts being added to our understanding in just a few months. Before we dive into the newest findings, let's do a quick recap. In my last video, I talked about how 3 I/ATLAS was discovered and why it's special. It's the third interstellar object ever recorded in our solar system, after Oumuamua in 2017 and Borisov in 2019. Compared to its predecessors, 3 I/ATLAS is much faster, zooming through space at about 58 kilometers per second, and it's believed to be very old, somewhere between 3 and 11 billion years. That's the quick background. If you want all the details, check out my first video, link in the description. Since then, astronomers have learned even more, thanks to countless hours of observations from top facilities around the world. So, what's the latest scoop? Because of all the attention 3 I/ATLAS has drawn, it's even caught the eye of 2 of the most prestigious telescopes in the world. Getting time on NASA's Hubble Space Telescope is notoriously difficult. Scientists usually have to submit detailed proposals months in advance just to get a few minutes of observation time. Luckily for 3 I/ATLAS, the Hubble Space Telescope always saves some time for what they call targets of opportunity, objects that need to be observed before they move out of reach. This meant our unexpected interstellar visitor got a rare chance to skip the usual long queue, and it was worth it. On July 21st, when the comet was 446 million kilometers from Earth, Hubble captured an incredible image. You can actually see how fast it's moving from the streaky stars in the background, and even notice the teardrop-shaped dust streaming off its icy core. These observations also helped scientists estimate the size of 3 I/ATLAS's nucleus. Turns out it's between 440 meters and 5.6 kilometers across, much smaller than originally thought. Early estimates assumed the light was coming entirely from the nucleus, not the surrounding coma. Now that the dust has cleared, scientists can study the comet in much finer detail, and future observations may refine these measurements even more. Another heavyweight turning its gaze toward 3 I/ATLAS is the James Webb Space Telescope. On August 6th, Dr. Martin Cordiner and his team used JWST's near-infrared spectrograph to study the comet's composition. They discovered that 3 I/ATLAS has a complex coma, with gases escaping in different patterns depending on the elements involved. At this stage, carbon monoxide and carbon dioxide were escaping more than water, though that might change as the comet gets closer to the sun. Interestingly, while comet tails usually point away from the sun, researchers saw a lot of dust moving toward the sun. This happens because dust grains break apart as they drift from the nucleus, reflecting more sunlight. The process might even be boosted by carbon dioxide, which could be pushing the dust farther out. Pretty dramatic for something that looks like just a hazy glow from Earth. Hubble and James Webb aren't the only ones keeping an eye on 3I/ATLAS. The Transiting Exoplanet Survey Satellite, TESS, which has been scanning the sky for exoplanets for over 7 years, can also spot smaller objects, including comets. In fact, astronomers realized that TESS had been capturing 3I/ATLAS all the way back in May, before its official discovery in June. Between May 7th and June 2nd, TESS collected deep stack images that allowed researchers to verify previous observations and even make some new discoveries. A study published on September 11th by Adina Feinstein, John Noonan, and Daryl Seligman looked at the comet's brightness using TESS data. They expected it to get slightly brighter as it moved closer to the sun, about 1.5 times more light. But the comet surprised everyone, getting much. Feinstein's team also tried to track the comet's light curve, a way to measure how it reflects light as it spins. Unlike Oumuamua, 3I/ATLAS has a very flat light curve, reflecting light evenly across its surface. The test data was too noisy to determine a precise rotation period, but they did detect two possible signals, one every 29 hours and another every 16 hours. Other ground-based telescopes support the 16-hour rotation, giving us a clearer picture of the comet's shape and spin. Space telescopes aren't the only ones providing exciting insights. On August 27th, the Gemini South Telescope in Chile used its multi-object spectrograph to capture multicolor images of 3I/ATLAS. These images revealed not just the coma, but also the comet's tail, which stretched about 1/120,000th of a degree in the sky, much longer than seen in earlier observations. Back in July, the Gemini North Telescope captured more stunning images of 3I/ATLAS. These observations show that the comet is becoming more active as it gets closer to the sun, and it hints at even bigger changes to come. Who knows how much longer its tail will grow before it reaches perihelion on October 30th. During the August observation session, researchers also recorded the comet's spectrum. Bin Yang, an assistant professor at Diego Portales University, spotted a clear emission feature in the CN band, proof that the comet was releasing cyanide molecules. This happens when sunlight warms a comet, causing water ice to sublimate, turn from solid to gas, which releases hydrogen cyanide. Sunlight then breaks it down into its component parts. Usually, we start seeing this process when comets are 2.5 to 3 astronomical units, AU, from the Sun, exactly where 3I/ATLAS is now. Other observatories have confirmed this trend, noting that the once weak CN signal is getting stronger over time. A paper published in early September estimated that the comet was releasing about 8 times 10 to the power of 23 cyanide molecules per second when it was just over 3 astronomical units from the Sun. That might sound huge, and it is, but it's actually on the lower end compared to many comets in our solar system. Scientists also measured the ratio of dicarbon, C2, to cyanide in the comet's coma. The result? 3I/ATLAS is carbon chain depleted, meaning it has very few longer chain carbon molecules, like C2 or C3. This is a feature used to classify comets and likely reflects the conditions where they originally formed. By their estimates, 3I/ATLAS produces less than 0.09 C2 molecules for every CN molecule, confirming it's highly carbon chain depleted. Interestingly, Borisov, the previous interstellar comet, shares this trait. hinting there might be a pattern in the makeup of interstellar visitors. That said, we only have a tiny sample size of interstellar comets, so it's too early to draw broad conclusions. Still, as 3I/ATLAS nears the Sun, things could change. Dicarbon production might rise, the comet could outgas more water, or something even more dramatic could happen. As comet expert Karen Meach puts it, these objects are really very fragile, dirty snowballs. They can break apart, which would expose fresh ice to sunlight and create a burst of emissions. But that's not all. Scientists have also been studying how 3I/ATLAS polarizes light. On September 5th, a paper by Zuri Gray and colleagues presented the first ever polarimetric observations of 3I/ATLAS, only the second time such measurements have been made for any interstellar object, the first being Borisov. Polarimetry is a technique used to probe physical properties of space objects, like the size of dust grains, the texture of their surfaces, and the shape of their coma. Gray's team collected data from telescopes in Chile, the Canary Islands, and Bulgaria, and discovered something truly remarkable. 3I/ATLAS has an exceptionally deep and narrow negative polarization branch. In simpler terms, this means the comet scatters light in a way we've never seen before, not just for comets, but for asteroids or any other interstellar object in our solar system. Even Borisov, which showed positive polarization, is different from this behavior. This could mean that 3I/ATLAS belongs to a completely new class of small planetary bodies that we know almost nothing about. To give a little more context, dust and gas around space objects can cause light to scatter in specific directions, which we can measure from Earth. Scientists look at the scattering plane, an imaginary line connecting the observer, the comet, and the Sun, and check whether the light is polarized perpendicular, positive, or parallel, negative, to that plane. And in the case of 3I/ATLAS, that light is polarized parallel, in a way that's strikingly unusual and unlike anything else we've seen in the solar system. The unusual deep and narrow negative polarization of light from 3I/ATLAS tells us that the comet is scattering sunlight in a very specific way, parallel to the so-called scattering plane. This is pretty. Molecules, causing them to fluoresce at a specific wavelength, around 518 nanometers, which our eyes see as green. Normally, this green glow is common for comets in our solar system. But remember, 3I/ATLAS was found to be highly carbon depleted, meaning it shouldn't have much C2. This could hint that C2 production has recently increased, though scientists will need more observations to confirm this. Whatever the explanation, it's a stunning sight, and it has both amateur astronomers and professionals buzzing with excitement. And now, we get to a name you've probably already heard in the media, Avi Loeb. Avi Loeb, a Harvard astrophysicist, has made headlines many times over the years for his bold ideas, and 3I/ATLAS is no exception. His recent focus on the comet has sparked a mix of fascination and controversy among scientists and the public alike. Back in July, Loeb began sharing his thoughts on 3I/ATLAS. One of his main points: the comet is huge. Early estimates put its radius at around 10 kilometers, which would give it a mass far larger than most interstellar objects we'd expect to see entering our solar system, making it a very rare visitor. Based on this, Loeb suggested that 3I/ATLAS might actually be smaller than initially thought, but he also floated a more controversial idea. What if this object isn't just a comet? What if it's alien technology? Just a few days later, Loeb co-authored another paper with two collaborators from nonprofit organizations focused on interstellar exploration. The title says it all. Is the interstellar object 3I/ATLAS alien technology? Early estimates suggested that the Comet 3I/ATLAS had a radius of about 10 kilometers. A.V. Loeb, a Harvard astrophysicist, pointed out that if that size were accurate, the comet would be far more massive than we'd expect from objects in interstellar space, making it an extremely rare visitor to our solar system. In response, Loeb suggested the comet might actually be smaller than initially thought. But then he proposed something far more controversial. What if 3I/ATLAS isn't a comet at all, but alien technology? Just days later, Loeb and two collaborators from nonprofit interstellar research organizations published a follow-up paper titled, "Is the Interstellar Object 3I/ATLAS Alien Technology?" While his first paper only hinted at this possibility, the second put the idea front and center. They analyzed the comet's motion and behavior, exploring whether it could be technological or even hostile. The authors referenced the dark forest hypothesis, which is a solution to the Fermi paradox. If you're unfamiliar, the Fermi paradox asks, why haven't we seen any aliens despite the vast number of stars in the universe? The dark forest idea suggests that maybe aliens are out there, but they're deliberately hiding, like prey avoiding a predator. Loeb and his team stressed that they were exploring this theory for educational purposes, and simply because it's fun to think about, regardless of how likely it actually is. Even in this paper, Loeb maintained that 3I/ATLAS was too large to be a regular asteroid. But as any scientist knows, early estimates for newly discovered objects often change as more measurements are taken and peer-reviewed. The original 10-kilometer estimate came before astronomers could properly measure the comet's coma, the cloud of gas and dust surrounding the nucleus, which actually accounts for most of the light we see. By August 7th, the Hubble Space Telescope had measured 3I/ATLAS at no more than 5.6 kilometers across, yet Loeb continued citing the older numbers. Even in an August 13th post on Medium, he referenced the Hubble images but still relied on outdated estimates. The takeaway? Exploring bold ideas is fine, but scientists must use the most credible data, especially for a discovery as new and complex as 3I/ATLAS. Loeb's other claims have also been challenged. A.K.M. Ihsanul Haque, a geoscientist from Petronas University in Malaysia, disputed Loeb's suggestion that the comet's path required deliberate, non-gravitational maneuvers to achieve a perfect flyby of Venus, Mars, and Jupiter. According to Haque, the comet's trajectory can be explained much more naturally without invoking alien engineering. For many scientists, this is a reminder to stay cautious. As fun as it is to shout aliens, it's smarter to let the data settle before jumping to conclusions. That way, if, and only if, the evidence points to something truly extraordinary, we can respond thoughtfully and effectively. As for 3I/ATLAS itself, the comet isn't slowing down, and neither is the science surrounding it. On October 30th, it will reach perihelion, about 1.4 astronomical units from the Sun. Unfortunately, it will be too close to observe at that time, but don't worry, by early December, it will reappear, giving astronomers another chance to study it. Missions like NASA's SOHO, SPHEREX, MAVEN, as well as continued observations from Hubble, James Webb, and the